All right, so last section of chapter 2.
So well designed.
All right, so what we're going to do is talk about different ways that we can prove angles congruent. So what I want to start out, first off, what we're going to do is when we prove something, once we prove something, we call it a theorem. So a theorem is something that we prove, a conjecture that we prove is true. And we prove conjectures true using logic, using deductive reasoning. We start from what we know is true and figure out what else has to be true. Once we prove a theorem, then we can use that as a reason in another proof. So once we prove that it's true, we say, okay, we know this, now we can use it as a reason. So I want to talk about something that we've talked about before, we've used before. We have said before that vertical angles are congruent. So we talked about this in chapter 1. And what I want to do now, we have the tools to prove that this is true. We talked about it, we accepted it, now we can prove this as a theorem. So let's draw a picture. And we're going to build a proof. Now, what I would ask you, or what I would expect you to be able to do, is like the ones that we did on the worksheet yesterday in class, or the ones that are in your homework, your proofs. Most proofs we're going to ask you to do where you're going to fill in the blank. So you're going to have a statement that you need to fill in and a reason you need to fill in. You're not necessarily going to come up with them from scratch right away, but eventually you will be able to. All right, so we want to, here's our picture, and we're given that angle 1 and angle 3 are, and we're just going to work with angle 1 and angle 3. We could do the same thing with 2 and 4. We're going to say are vertical angles. And we want to prove that angle 1 is congruent to angle 3. So let's go through. So I'm going to put my statements. We'll do a 2-column proof. So I'll put my statements over here and my reasons over here in this column. So let's start out with our given. We don't always start out with our given, but we don't have much to go on here. So let's start out with our given. Angle 1 and angle 3 are vertical angles. So that's given. So what we're going to do, we want to use things that we already know to try to get to this piece that we're trying to prove. So let's look at angle 1 and angle 2. Our proof has to do with angle 1. Let's look at angle 1 and angle 2. What do we know about those two angles? They're supplementary, right? Isn't that just like we talked about on our opener? Angle 1 and angle 2 are supplementary. And what did we say a reason could be for that? What do we call those two kinds of angles? Linear pair. We know a linear pair is supplementary. So I'm going to say linear pair. And because the other angle we're looking at is angle 3, let's look at angle 2 and angle 3. What do we know about angle 2 and angle 3? They're also supplementary. So I'm going to say angle 2 and angle 3 are supplementary. And our reason is exactly the same. They are linear pair. All right, we figured this out on our opener also. What can we say about supplementary angles? They add to 180. So let's write that down. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. And the measure of angle 2 plus the measure of angle 3 is 180 degrees. And for that we could say, because they're supplementary, we could say the definition of supplementary, something like that. I can just say supplementary. That's what supplementary means. They add up to 180. All right. Now we have two things. This top line that adds up to 180 and this bottom line that adds up to 180. What does that tell us about how measure of angle 1 plus the measure of angle 2 compares with the measure of angle 2 plus the measure of angle 3? They're both 180. So how do they compare to each other? They are, remember, and we're talking about numbers here, so not congruent. They are equal. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. They're the same thing. Same thing means equal. So let's write that down. Measure of angle 1 plus the measure of angle 2. Guys, stop please. Equals measure of angle 2 plus the measure of angle 3. Now what I've done here is, let me highlight here. We know that this equals 180. So I've taken this whole thing and I've put it in here for that 180 degrees. There, it's equal to 180. So what do we call it when we put something in place of something else? Substitution. Very nice. So my reason here is substitution. All right. Now we have an equation. We have the measure of angle 2 on both sides of the equation. There's measure of angle 2 and there's measure of angle 2. Let me use a different color then, because I already used blue. Use green. If I have the same thing on both sides of an equation, what can I do to get rid of that thing? Subtract it or add it. And we're talking about angles, so it's going to be a positive number, so we're going to want to subtract. So if I subtract the measure of angle 2 from both sides, I get the measure of angle 1 equals the measure of angle 3. And that's going to be subtraction. Well, isn't that, we're almost to what we were trying to prove, right? We were trying to prove that the angles were congruent. We said the measures are equal. Well, doesn't that let us say angle 1 is congruent to angle 3? Yeah? And what would we say our reason for that was? Isn't that what congruent means? That their measures are equal? So we could say this is definition of congruent, or we could just say because they're congruent, or because their measures are the same, something. So this, we could say something like definition of congruent. We say they're congruent, we mean that it's the same thing as saying their measures are equal. And we're done. So, not too bad. Not too bad. Questions on that? All right, guys, knock it off. All right, so this is how we go about proving, constructing proofs. Now we know, now we've proved that vertical angles are congruent. We accepted it before, now we proved it. We can use a similar process to prove other theorems about congruent angles. So I want to write a couple of those down, and we'll do one more proof. So let's write a couple of these other theorems down. We're only going to prove one of the others. The first one is all right angles are congruent. So if we have, so this is one theorem. All right angles are congruent. So if angle 1 and angle 2 are right angles, that tells us that angle 1 is congruent to angle 2. And this one's a really easy proof. We'd say the measure of angle 1, that's a right angle, is what? 90. Measure of angle 2 is 90. Substitute measure of angle 2 for 90 degrees, and we get measure of angle 1 equals measure of angle 2, and that tells us they're congruent. So that one's really easy. All right angles are congruent. Straight angles, we could say the same thing for straight angles. We use right angles more than straight angles, so that's why we said this here, but yeah, that would be correct. How about, I want you guys to see if you can figure it out. Angles that are congruent and supplementary. Are what kind of angles? What was it? Right angles. Very nice. They're congruent means they have the same measure, and supplementary means they add up to 180. So if they have the same measure and they add up to 180, they have to be right angles. Very nice. That was very fast. So that is a theorem that we can use. If two angles are supplementary and congruent, they're right angles. And in symbols we'd say angle 1 congruent to angle 2. Measure of angle 1 plus the measure of angle 2 equals 180. So measure of angle 1 and measure of angle 2 equals 90 degrees. So just another way to write that. So that's another theorem now that we can use when we're dealing with showing that angles are congruent. We'll write two down that are similar, and we'll prove the very last one. All right, questions before we go on? Okay. Congruent supplements. So we're going to say that two angles supplementary to the same angle are congruent. So if we draw a picture here, I know the picture's not drawn to scale. Drawer. All right, so we're going to say angle 1 and angle 2 are supplementary. And we're going to say angle 2 and angle 3 are supplementary. What this says is so angle 1 is congruent to angle 3. Angle 1 and 3 are congruent or supplementary to the same angle, so they are congruent. And really what this is saying is we're adding something to an angle to get 180 degrees. If two different things add to that angle to get 180 degrees, those two different things have to be the same number. All right, questions there? Let's write down one more that's very much like this one, and then we'll do the proof for that one, and then we'll be done. Congruent complements. This is exactly like the last one, like our last theorem, except we're talking about complements instead of supplements. So we're going to say two angles complementary. And complementary means what? They add up to equal complementary 90 degrees. Two angles that are complementary to the same angle are congruent. So basically the same picture. So 1, 2, 3, and we're going to write the same thing but with the words complement instead of supplement. Angle 1, I'm going to write angle 2 are complementary. Angle 2 and angle 3 are complementary. So angle 1 is congruent to angle 3. This looks kind of a little bit like the transitive property, doesn't it? Angle 1, we're kind of linking these two together, but these two end up congruent instead of, they're not complementary also. All right, let's prove this one. This one is a lot like the last one we did. So statement and reason. I'm not going to rewrite this piece, so let's just draw an arrow so we don't have to rewrite all that stuff. So that's going to be our given. So our given is this box, and our first statement is going to be that. That's going to be our first statement. All right, so complementary, what is, if these two angles are complementary, what else can we say about them? They add to 90. So let's write that down. Measure of angle 1 plus the measure of angle 2 equals 90 degrees. And measure of angle 2 plus the measure of angle 3 equals 90 degrees. And that's because they are complementary. We could say definition of complementary. What complementary means. All right, now we're at the same place we were in our last proof, aren't we? These two both equal 90. So what can we say about this piece and this piece? They equal each other. They're the same. They're both 90 degrees. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what was our reason there? We took this measure of angle 2 plus measure of angle 3 and we stuck it in here in place of 90 degrees. And we put something in something else's place. Substitution. And then we have a measure of angle 2 on both sides of my equation. So what can I do with that measure of angle 2 to get rid of it? Subtract. So I get measure of angle 1 equals a measure of angle 3. Subtraction, and then we can say angle 1 congruent to angle 3. And that's going to be our definition of congruent. And we're done. Just like the last proof, same idea. Yeah, there are a lot of words in this in chapter 2. Less words in chapter 3. All right, questions there. So this is the kind of thing that we're going to move towards doing. We don't do it. Not every problem is going to be a proof, but we do prove a lot of things. Proving things is a big thing, big process in math. Math is really about proving things, proving theorems. The application, solving problems, that's getting more towards applied math. This is what you do when you're like this is sort of what a mathematician does. What can I figure out from what I know? Proving theorems. And sometimes they have interesting applications, but the idea of math is doing the proving. All right, homework. There's the homework.